Okay, so we're going to start talking about equations involving indices and surds. And one thing that is going to be true is this. If we have some positive number, oh, excuse me, so some positive number, we're going to call it a, and a is going to be greater than 0. And also, we're going to say that a can't be 1. So any positive number other than 1. We're going to say that this is true. That if a of x equals a of t, and really this is a biconditional thing. If that's true, then x has to equal t. So if you have the same base, a, and they have exponents that may or may not be identical, so, they could be different letters, they could be different variables, different forms of the same thing. It's saying that if that equation is true, if you're saying that one base to an exponent equals one base to another exponent, then the exponents have to be the same. That has to be true. So the example that I have on your sheet says, what if you have 3 to the x minus 4, and that equals 9 to the 5 minus 3x. Well, this, okay, is not the same base, so we can't make a direct relation between x minus 4 and 5 minus 3x. We have to get them to have the same base. But if they do have the same base, then we can say something. So this requires us to make a step. So one thing that we know is that 3 squared equals 9. We know that this is true. So we're going to use that. So we're going to say, okay, so we got 3 to the x minus 4. That equals, well, 9 is the same thing as 3 squared. And we're taking the 9 to the 5 minus 3x power. Well, it may look complicated, but when we raise an exponent to another exponent, all we do is we multiply those two things. And remember, you're multiplying by the whole 5 minus 3x. That's an entire exponent. So this is going to be 3 to the x minus 4 equals 3 to the 2 times 5 minus 3x. So now we actually have two like bases. They're the same. And our rule says that if we have this situation, now there can't be any additional fluff, like no plus anythings, nothing like that. If we have this, then we can make a direct relation between these two things. We can say that x minus 4 is going to equal 2 times 5 minus 3x. And we can go forward and solve for x down the line, but that's not the point of this video, is to solve for it. The point of this is to show you that this has to be a true statement. There is one other statement as well, and that's if you have, let's say, a plus b times the square root of n, and that equals c plus d times the square root of n, where a, b, c, and d are rational numbers. Okay, and the square root of n is a surd. Then we can say that a equals c and b equals d. So what it's saying is if you have this same similar type setup, okay, where you have, some sort of surd with a coefficient, it can have a coefficient or not, that those two relate to each other just like the parts without the surd relate to each other. So this is just matching parts. I mean, you're differentiating the parts in that one of them has a surd attached to it, and the other one does not. And so if you had an equation like that, you could automatically assume, you could go ahead and say, yes, this and that are the same thing.